But the whole idea that you put pressure on a rubber band and this is proportional. That is, 1 pound moves it this far, 2 pounds is this far, 3 pounds is this far, 4 pounds. That obeys Hooke's law. This isn't that challenging a test for him to do, is to take his device and orient it in such a way where he can just put the masses on and see if they actually measure, properly. There's actually a scale that works.
This is the height without weights. This is a 1 mass attached to the rubber band. 1 mass. This is a 2 mass attached to the rubber band. 2 mass. Here is a 3 mass attached to the rubber band. 3 mass, 1 gram too much. Here is a 4 mass attached to the rubber band. 4 mass, 1 gram less. So as can be seen, the rubber band without any weights is aligned with 10 centimeters perfectly. Then with the 1 mass attached, we have 8.9, which is a stretch of 1.1 centimeters. Then with 2 masses attached, it goes to 7.9, which is another 1 centimeter stretch. Then 3 masses measures to 6.8 centimeters, so that's a 1.1 centimeters extra stretch. And then a 4 mass attached to it, we have 5.9, so that's another 0.9 centimeter stretch. So on average, we have around 1 centimeter stretch per 1 mass extra that we add onto the rubber band. So it's a pretty linear relationship. This confirms Hooke's law. The rubber band works just fine. However, when we drop the masses horizontally, we do not get linear proportions. Then the amount of stretch is proportional to the square root of the mass. So once again, these are my results. If you do not believe these numbers, go watch the video again. So we have the 1 mass 1 height, 2 mass 1 height, 3 mass 1 height, 4 mass 1 height. All right, so the 1 mass 1 height is 4.75 centimeters of stretch. If you want to predict the 2 mass 1 height, then we would have to do 4.75 times the square root of 2. That equals 6.71, and my result is 6.63, so that's pretty close. Then for 3 mass 1 height, the prediction is 4.75 times the square root of 3, which is 8.22. My result is 8.15, pretty close. Now for the 4 mass 1 height, the prediction is 4.75 times the square root of 4. That is 9.5. My result is 9.1, pretty close. Then I also have the 1 mass 2 height, the 2 mass 2 height, the 3 mass 2 height, and the 4 mass 2 height. This is 6.4 centimeters, so the prediction is for the 2 height, 6.4 times the square root of 2, which is 9.05. My result is 9.075, pretty close. Then the 3 mass 2 height, 6.4 times the square root of 3, which is 11.08. My result is 9.7. Yeah, pretty close still. Then 4 mass 2 height, 6.4 times the square root of 4 equals 12.8. My result is 12.45. Pretty close. Everything is pretty close to the predictions. The results and predictions are in line. Physics works. There is no problem with this experiment.
But anyway, he says there's no goddamn parallax problem. So he's taking an image of the same thing. I'm saying it's the same event. And he's taking the image from 2 different camera locations, and he's saying there's no parallax problem. It's impossible to say that. So the video is goddamn shit. Okay, so I'm not even going to watch it. Because bullshit. This is all I'm calling. Can't evade it. Even if you had a decent camera, you couldn't evade the parallax problem. All right, so.
Thank you once again for pointing out that you're just an insanely pathetic evidence denier. You don't care about physical evidence, you only care about your own intuition. Your science is intuition science. It's not based on evidence, it's only based on intuition. I have pointed out, I have recorded the same event from three different locations, and each time you can see the same reading on the ruler. You didn't even bother to watch it. Of course you didn't bother to watch it, because you don't dare to watch the truth. You don't dare to face the truth. Here's the 1 mass, the same event. So 33.2, then I move the camera more to the left. I repeat the same event, and I read 33.3, only 1 millimeter in difference. I once again move the camera more to the left, so the 3rd location. I repeat the same event, and what do I see? 33.3. No difference, absolutely no difference. And here you are claiming, yes, there is a parallax problem. No, there isn't. I have physically proven it with real physical evidence. You don't. You only use your own intuition. You don't care about physical evidence. You're a fucking pathetic evidence denier. God damn you.